Hello all, welcome to my course on methods of adhesion measurement, theory and practice. We are discussing about contact mechanics with interaction, and this in essence what we have are two spheres which are in contact, and a contact load of pressure P0 has been applied. If there is no interaction between them, the contact radius will be A0, but as there is interaction between these two spheres, adhesion between these two spheres, the contact radius increases to A1, and this problem was analyzed by Johnson, Kendall and Roberts, and that is why it is called the JKR contact mechanics. So, here in the last lecture we decided that we are going to solve this problem by considering the total energy in the system. In the energy total energy, the elastic energy of these two spheres have to be calculated, and so we thought that we will do this in two steps. In one case, we increase the pressure from 0 to P1 by Hertz mechanics, and so therefore, the contact radius increases to A1, and then by the adhesion, because of adhesion the pressure is decreased from P1 to P0. So, in that regime, as I said it earlier, that the pressure will be equal to P0 dash and square root of 1 minus R square by A square. This corresponds to a flat punch. We know that for that the contact radius remains constant, the depth of indentation that decreases the pressure also can be decreases. So, here P0 is essentially negative. So, pressure is decreased from P1 to P0. So, in the last lecture we estimated that what is the area, what is the energy that will be required or that gets stored in the spheres because of this action, that the pressure increased from 0 to P1, because of which the depth of indentation increases from 0 to delta, and the delta is given by this. So, d delta is this, P into d delta is this, and so we integrated that and we obtained this. So, this is the first part. Now, let us say the pressure will be decreased from P1 to P0. So, correspondingly what is the delta here? So, the delta will be coming from for this kind of pressure distribution, and that we have derived it earlier, and that is given by this equation P by 2 A1 into E star. So, that we have derived quite a few lectures earlier, where we have considered the pressure distribution like this, and for that what is the vertical deformation of this elastic half space that we have considered, that we had estimated, and that came out to be this equation P by 2 A1 into E star, where E star I can replace by writing in terms of this term capital K. So, this is pure convenience. So, K capital K is equal to 4 E star by 3 here, and so we replace E star by K here. So, it will give rise to this equation. So, now in order to find out this part of the energy, elastic energy, what we will consider is that pressure is decreased from P1 to P2, and P into d delta is the energy, infinitesimal energy. So, therefore, we calculate over here d delta. So, d delta, remember A1 remains constant here. So, it is dP by 2 A1 into E star. So, now you substitute over here. So, it will be P1 to P0 into this is P into d delta. So, d delta is dP 2 A1 E star. So, that is equal to, this is P square by 2, it is 2 here. So, it is 4 A1, this is E star, this is P square, this is P1 here and P0 here. So, this is 4 A1 E star, and this is P0 square minus P1 square. And noting that A1 can be written in terms of P1. So, by this equation A1 cube is equal to P1 R by K that we have obtained earlier. So, here I will replace this A1 over here. So, it is 1 by 3 capital K, and A1 will be equal to P1 into R by capital K to the power 1 by 3 here, and here it is let us say P0 square minus P1 square. So, if I further write it, it will be 3, this is K to the power 2 by 3, R to the power 1 by 3 here, and then here it is let us say P0 square by P1 to the power 1 by 3 minus this is P1 to the power 5 by 3, like this, because it is P0 square there and this is P1 here like that. So, essentially what I am trying to do is write in terms of P1, because later on I am going to derive it, minimize the total energy with respect to P1, that is my intention. So, here it is written. So, now this is the total energy of the stored in the spheres, that is U1 plus U2. So, U1 plus U2. So, U1 I have already derived from here, this is 2 by 5 P1 to the power 5 by 3, K to the power 2 by 3, R to the power 1 by 3. So, here so here it is, therefore, P to the power 2 by 5, this is U1 P1 to the power 5 by 3 by K to the power 2 by 3, R to the 1 by 3, and here I have just derived this expression over here. So, this is this. Remember that here P0 square minus P1 square, and so you can take this minus out. So, this quantity P1 is actually larger than P0. So, this quantity is actually positive. So, this quantity is positive. So, in essence what it means is that in the Hertz contact pressure you gave some extra amount of energy, and that you subtracted during the work that is done by this adhesion force, basically that aspect. So, that is how it comes, it has to be interpreted. So, in any case this is the expression of the total energy. Now, what is the mechanical energy of the external load, that needs to be understood. So, you see that what is the mechanical and external load, that will be equal to, this is should be minus, because the external load has spent some amount of energy. So, it is minus here, and the external load was P0, this P1 was a fictitious load. Okay. Actually the load has been applied is P0 only, P0, and this P0 has travelled some distance. Okay. So, that has to be understood. So, here what is the distance that P0 has gone through? So, see, when the load was increased from 0 to P1, okay, the P0, the load actually went from the distance that was travelled from 0 to delta 1 here, okay, because this is the Hertz pressure. So, when you went from, this is blue is the delta versus P here. So, when you increase from pressure from 0 to P1, okay, the delta actually went over here, that is delta 1. So, when you consider here, we have to have delta 1 that we have gone, and then it has gone to the second state, it has gone from delta 1 to this distance, because now the pressure has been decreased to P0. So, the delta, the displacement or the deformation, that has been decreased to this value over here, somewhere here. So, this quantity has to be considered. Now, that quantity, how do I estimate that? So, that can be obtained easily. So, let us see, that can also be obtained from here, let us say. So, here let us say that this d delta is given by this the second part, the delta was given by this. So, d delta is this. So, now we integrate from P, going from P1 to P0, and for that the delta goes from the delta 1 to delta 2. So, the final distance that the load displacement happens is up to this distance delta 2, and so delta 2 will be given as delta 2 is equal to delta 1 plus this distance over here, that is 2 by 3 K1 into P0 minus P1. So, in this plot finally it reaches this particular distance, P reaches this distance, right. So, this distance here, that is actually delta 1, that was this quantity plus this quantity. Remember that this quantity is actually negative because P1 is larger than P0. So, we are all right, we are actually coming back to this particular point, which is given by this expression, and delta 1 is given by this expression. So, therefore, the load that mechanical load potential energy, that will be this quantity, first of all delta 1, and then this quantity which is up to the decrease in that from delta 1 to this distance delta 2. So, the total distance that this travels is this quantity. So, that is given by the whole thing is given by this. So, this is minus P 0 into this is the whole distance through which this load travels, or load has to mechanical external load has to go through the distance. So, force into distance is energy. So, the mechanical potential energy of the system, or the energy that is spent by this external agency, that external load, that is given with a minus sign here, minus into P 0 and this, and then the energy that has gone because of the adhesion of the two surfaces. So, the initially these surfaces are higher energy, okay. Now they have brought together, so there is an energy decreased. So, from here to here, so there is an interfacial energy there, energy minus this energies over here. So, therefore, there is a decreasing energy of the surface, because two surfaces are come together and formed an interface. So, the adhesion can happen only when the energy decrease. So, their energy is decreased. So, now the interface has this energy minus pi a1 square into W a, whereas W a is equal to gamma 1 plus gamma 2 minus gamma 1 2. So, that we have defined earlier. So, this is the energy amount, the thermodynamic quantity of energy that is there, that happens when this corresponding to this the energy that decrease, that happens when the surfaces are brought closer together. So, this quantity is called thermodynamic work of adhesion. So, this is the quantity which is called thermodynamic work of adhesion. Okay. So, total energy now we have to consider, total energy will be considered. So, that will be the summation of all this energy, that is here A1 has to be represented also in terms of P1, that we have done. So, the total energy of the system will be written like this: ut is equal to ue plus um plus us, and that gives rise to this equation. So, this is from ue part, this is from the u0 part, and then this is W work of adhesion. So, all together it comes out to be like this. So, now we can, equilibrium is attained, the minimum energy of the system is reached. So, that we can do by writing del u t by del P1, okay, that is equal to 0. So, either you write it in terms of A1 or in terms of P1, does not matter. Okay. This P1 and A1, they are actually linearly related, that you have seen. So, therefore, it does not matter, you write it with respect to P1, essentially you are actually minimizing with respect to A1. So, basically what we are saying, that under these conditions, what is the A1, at which value of A1 the minimum energy is attained, basically that. So, now this quantity will be therefore is equal to, I will just quickly do it, 2 by 3 r to the power 1 by 3 here, this is 115, and this is 5 by 3 P1 to the power 2 by 3 here, because 5 by 3 minus 1, and then minus this is 1 by 3 into 1 by 3 into P0 square, and this is P1 to the power minus 4 by 3, and then minus here 1 by k to the power 2 by 3 r to the power 1 by 3 here, this is P0 by 3 into 2 by 3 into P1 to the power minus 1 by 3, and then minus 2 by 3 P0 square, this minus is coming because minus 1 by 3 was there, this is P1 minus 4 by 3, minus this is W adhesion, work of adhesion, this is pi, and here it is r to the power 2 by 3 by k to the power 1 by 3, this is 2 by 3, and this is P1 to the power minus 1 by 3, and the whole thing is equal to 0. So, it is like that. So, little algebra there, that is true, but that can be taken care of. And now, let us say we further simplify this equation. So, here let us say we multiply by 2 by 3 into r to the power 1 by 3. So, here it is 5 here, sorry 3 here, sorry about that, it is 3 here, this is 15, this is 5, 3 here. So, it is 3 here, it is 1 by 9. So, let us see once again what happens here. So, this is 1 by k to the power 2 by 3 r to the power 1 by 3 here, and this is 1 by 9, this is p 1 to the power 2 by 3 1 by 9 minus this is 1 by 9, this is p 0 square p 1 to the power minus 4 by 3, and then minus this is 2 by 3 such as okay. So, this is fine. So, this is k to the power 2 by 3 into r to the power 1 by 3, this is 2 by 9 here. So, it is 2 by 9 here, this is p 0, this is p 1 to the power 1 minus 1 by 3, and minus again there is 2 by 9 here, this is 2 by 9 here, and this is p 0 square here, and this is p 1 to the power minus 4 by 3 here, and then here it is minus this is 2 by 3 here w a pi, and then here it is r to the power 2 by 3 to the power 2 by 3 k by k to the power 1 by 3 and p 1 to the power minus 1 by 3, this is equal to 0. So, now we can multiply all the sides by k 1 to the power 2 by 3 r bar 1 by 3 and further simplify it. So, further simplifying all these things gives rise to finally this expression, this into this over here leading to this expression. So, here, so up to this point we already obtained, and now you multiply it and take out this p 1 to the power minus 4 by 3 outside. So, you get here p 1 0 square minus p 0 square, and here you have minus 4 by 3. So, it is minus 4. So, it becomes 2 p 0 square here minus this quantity minus 2 p 0 p 1 over here, and from this point this term we get over there. So, in essence what we have is this equation simple. Now, it looks quite simple, p 1 square minus 2 p 1 into this and then plus p 0 square is equal to 0, and so we can solve this for p 1, and so p 1 will be equal to 2 into p 0 plus 3 w a pi r plus minus b square minus 4 a c. So, it is let us say 4 into p 0 plus 3 w a pi r square minus 4 p 0 square by 2. So, we need to consider plus minus. So, we consider the positive term only, right. So, if we do that and here so then it will be equal to p 0 plus 3 w a pi r plus this is divided by 4 it is p 0 square. So, p 0 square gets cancelled. So, here it will be 2 into 3. So, it is 6 w a pi r plus 3 w a pi r square like this. So, yeah, so it comes out to be like that. And so, now stable solution. So, for the sake of stable solution we do not take the negative sign here, okay. We take the positive sign over here that way. So, we can also obtain the, remember that we want to obtain the a 1. So, a 1 cube. So, therefore, we can write here a 1 cube is equal to 3 r by 4 e star is actually 4 e star. Remember 4 e star by 3 is equal to k, that is what we are writing. So, into p 1, okay. So, this is p 0 plus 3 w a pi into r plus square root, this is 6 w a pi p 0 into r plus 3 w a pi r whole square like this. So, this is the relation between a 1 and p 0 in presence of w a, and notice that if we write w a is equal to 0, let us say w a is equal to, that means no adhesion, then a 1 cube will be equal to 3 r, this is 4 e star and w is equal to 0. So, I will have only p 0 here, and that will match with that Hertz mechanics the relation for W A 1 okay, for an applied load P contact load P 0. So, this will match with that Hertz load, no issues there. So, therefore, it works. So, now what it shows is that when you have this P 0 amount of load that is applied, and then you have kind of work of adhesion, some amount of interaction between these two spheres, then the actual contact of area A1 that actually increases over what would have been achieved with only P 0, that is what it shows. So, here so for K 1, K will be written as 4 star by 3 and we can actually replace it. So, let us say that what happens at 0 contact load. So, at 0 contact load, that means P 0 is equal to 0 here, let us say, right. So, if the P 0 is equal to 0, then A 1 cube will be equal to, let us say it is R 4 star by 3 is K. So, it is K here and then it is 3 W A pi R and this is 0 here. So, plus from here I will get another 3 W A pi R. So, you see here I am getting 6 W A pi and this is R square R into R, R square by capital K, right. So, let us check whether the units are fine or not. So, W A has the unit of millijoule per meter square and R has the unit of meter square and here K has the unit of Newton per meter square, Newton per meter square, meter square, So, therefore, millijoule is Newton meter. So, so this meter square goes and joule means it is Newton meter. So, Newton goes, it is meter cube, fine, we are fine actually. So, this A 1 cube is equal to this. So, what it means is that even when the load is 0, okay, there is a finite contact radius that occurs because of this work of adhesion and this is experimentally found and that actually is captured by this particular equation. So, that is there. So, finite contact radius remains because of adhesion and vanishing work of adhesion that I have already described this condition that we get back the Hertzian contact mechanics, the contact radius for that purpose. Now, there is another interesting point here is that real solution for A 1 to exist. Let us say when the real solution exists, this quantity should be greater than 0. So, 6 W A pi P 0 into R plus 3 W A pi R whole square, that should be greater than equal to 0. So, what it means is that P 0 okay, is greater than minus of 3 W A pi R whole square divided by 6 W A R, yes, R. So, this quantity will be minus of, this is 3 into 3 9 by 6. So, it is 3 by 2, this is W A and this is pi R. So, it is pi into R. So, this is the pull of load that is required. So, that means that the load has to be larger than this quantity. Now, here remember that we have this particular sphere and let us say this particular sphere. So, they are in contact. So, the contact area has formed, this is one sphere, this is another sphere. Now, you are applying, you are trying to pull them out. Okay. So, if you pull them out, then the contact pressure, so it is P 0 is pressure. So, pressure has to be negative, there is a pull of force. So, this is actually negative now, and so what is the force required to separate these two spheres in presence of this work of adhesion between them, that is what we are estimating. So, we are trying to estimate what? We are trying to estimate what is the pull of load required to separate these two spheres, and because these two spheres are in contact because of adhesion. So, how much amount of force has to be applied? So, the force has to be applied is will be given by this P 0 is equal to 3 by 2 W A pi R. So, as the pull of force increases beyond that, then the A 1 basically will go to 0, the contact will go to 0 because there is no real solution beyond that. Okay. So, this is the pull of load that is applied for this particular case, that is all it means. Okay. So, this is the pull of load. Now, we will like to get an expression for the work of adhesion a little bit more in a more simplistic way. So, that is what we will do now. So, let us say we need to just rearrange this equation. So, let us say that is A1 cube and 4 star by 3 is equal to k. So, let us say that is k by r is equal to P0 plus 3 WA pi r plus square root of 6 WA pi P0 r plus 3 WA pi r whole square. Now, let us say I bring this part in the left hand side. So, and then square it. So, it will be A1 cube into k by r minus P0 minus 3 WA pi r square. So, this will be equal to 6 WA into pi into P0 into r plus 3 WA pi r whole square. So, here I will write it like this: A1 cube k by r minus P0, this is square, okay, minus 2 into, let us say A1 cube k by r minus P0 into 3 WA pi r plus 3 WA pi r square, and this is equal to 6 WA pi P0 into r plus 3 WA pi r square. So, if you see, we actually this term gets cancelled, and this is minus 2 P0 into minus plus. So, this also gets cancelled. So, in a sense what we have is something like this. Now, you see WA I have here as A1 cube k by r minus P0 square, and then I have actually here. So, what I was tell you that here I multiply minus 2, so plus 2 P0 into this term. So, that is this term, so that gets cancelled. So, I am left with this term. So, this term and bring it to the left hand side. So, therefore, it will be 6 here, and then it is 6 pi r, and it is divided by 6 pi r divided by A1 cube k by r, like this. So, this r gets cancelled, and so 6 here will be there, and we can simplify it. So, finally, I will get something like this expression, that is what I was trying to get. So, it is k1 cube, so I got it actually A1 k into A1 cube by r minus P0, that is square, by 6 pi A1 cube, right. That is what it is equal to work of adhesion. So, suppose if we know P0 and if you know let us say A1 and k, you can actually calculate what is work of adhesion. I will stop here today. Yeah, I will present several examples of this work of adhesion in the next lectures. So, thank you for your kind attention.